Travis from Finetech, going to talk about indium bumps for flip chip bonding. We heard about Finetech before from PolarLight. You had a nice collaboration with them. And now we're going to hear more about your technology and equipment and capabilities. Thank you.
All right, thank you. Yeah, I missed PolarLight's talk. I'm here in Taiwan, actually, so it's like getting pretty late. I'm doing some indium bonding this week with some customers in Taiwan, and then going off to China next week to visit a few there as well.
That's good.
So
good. Yeah,
we're busy.
it's good. Yeah.
All right, so I'm from Finetech, and we're presenting the Indium Bump Interconnect technology for micro-LEDs. So we'll just go over briefly what Finetech is, or who Finetech is, some general points about Indium Bump Interconnect, and then Indium Bump Interconnect for micro-LEDs. So Finetech is a sub-micron die bonder manufacturing company. We specialize in advanced packaging, microassembly, and rework. We also offer, paid application development and technological developments. So any sort of new technologies or product segments or markets that are coming out or applications to serve those, we do offer paid services to develop those with customers. And we are a worldwide company, so we're headquartered in Berlin, and then we have Finetech dedicated sites around the world with some representatives as well. So today we'll be focusing on high density micro indium bump interconnections for micro LED displays. These are also found in quantum computing processes or superconducting processes, IR thermal imaging display sensors, and micro LED displays. So what we see is as resolution is increasing, the bumps are getting smaller and more tightly packed. So we specialize in die bonding. We offer application services, worldwide company. So this is where we ended up. So application is micro LED displays, as well as quantum and superconducting chips, focal plane arrays, IR thermal imaging devices, and micro LED displays. So one of the main trends we see in this market is the bumps are getting smaller as the resolution is getting more and more dense, getting down to 2.5 microns and smaller that we're seeing now with some customers. And we also have a lot of requests from customers moving towards like multiple chips on a substrate, like a focal plane array, and chip to wafer, and I think wafer to wafer for IR thermal imaging devices. So what we see with micro LED displays is as they're getting closer to your eyes, so for example, polar light, the displays are getting smaller and smaller while the pixel density is getting denser and denser. For quantum computing, because of the requirements for Joseph junctions and communicating and controlling across them, there's no way of scaling that down to a smaller size. So the only way is to scale up in terms of the chip size. So what we're currently working on at the moment is chip on substrate. And what we're seeing as big requests from customers in the market is either monolithic stacking or horizontal spreading. And then focal plane arrays, so these are like thermal imaging sensors and detectors. There's also some other neighboring ones like ultraviolet and so on. And we see at the moment also chip on substrate assemblies going towards chip on wafer, and then Sony is also releasing like a copper wafer to wafer process for IR thermal imaging devices. So generally the challenges and the requirements for all three of these markets are very similar because it's very small, very dense indium interconnections. So indium bumps are vacuum deposited onto the substrates in most cases. Sometimes they are plated on. And they have the benefit of a low melting temperature of 157 degrees Celsius. They can be vacuum deposited down to 2.5 microns, and they're getting smaller, as we see from some customers and suppliers. They can be bonded using cold compression bonding. So cold compression bonding avoids thermal expansion. It avoids some sort of accuracy issues, oxidizing the indium, and so on. We can also do thermal compression and reflow bonding. And so cold compression bonding also supports cryogenic applications.